Okay, so I hope my screen is visible, right?
Yes, sir.
Okay. So today we will discuss about the thread priorities and daemon threads and non-daemon threads. Okay, and the next one is deadlock situation. Okay, and starvation. The last one is producer and the consumer problem. Okay, we will cover these four topics, so which are very important to understand the multi-threading. If you want to work on any multi-threading programs, so you need to understand these topics, which I'm going to explain now. So, what is thread priority? We will start with the thread priorities. For example, okay, in the Java programming language, you have an option to create many number of threads, right? For example, let us say that you have created two user-defined threads. Let us say that this is T1 and this is T2. So you have two threads. I'm not mentioning here about the main thread. You have two different threads. Okay. So let us say that these two different threads are going to invoke two different run methods. So it is mean to invoke the run method, right? So whatever the logic inside the run method, that will be executed by this independent threads. It is mean to invoke this run method. But you have an option to give the priority. When I say the priority, it is like, okay, you through the program, you contact the OS through the JVM. With the help of the JVM, you take the appointment of the OS. So let us say that this is OS and this is JVM. So the combination of OS and JVM will ensure that which thread is going to get the priority. Okay, they actually decide the which thread is going to get the priority. So there is a concept called thread scheduler, right? Thread scheduler. Okay, so this thread scheduler, let me tell you, strictly speaking, this thread scheduler is completely controlled by the operating system, not the JVM. This thread scheduler is completely controlled by the operating system, OS, not the JVM. But OS will combine, the JVM will combine with the OS just to ensure that, just to do a small kind of communication. What kind of communication it does? Basically, it will communicate like how many threads are created, okay, which thread is going to execute which method, which thread has priorities. Such kind of communication will be given to OS by the JVM. So the complete control of the thread scheduler is on top of what? Is on top of the operating system. Operating system controls the thread scheduler. Okay, if the operating system had to decide which thread has to get the time slice, which thread has to get the time slice, okay, OS will decide whether T1 or T2 who is going to get the respective time slice. Will be cycling between these two threads. It is completely controlled by OS. But what does the thread priority means? You as a developer have an option to give priority to a separate thread or to increase a priority to a separate thread. So you can say P1 thread should be the high priority thread. Okay, through the program, you can mark the P1 as the high priority or the maximum priority. And you can say through the program, you can say T2 thread as the minimum priority. Okay. So what kind of information we are conveying it to the OS here? When you say, okay, T1 has to be given the high priority, the JVM is trying to convey to the OS saying that a thread scheduler, please ensure that T1 is getting the highest priority among these two threads. Please ensure that T1 is getting the highest priority among these two threads. So what you are conveying through the JVM, we are conveying that the thread T1 should execute its tasks first, then the thread T2 has to get its task executed. This is a kind of convey, okay, this is a kind of convey that you use JVM to convey it to the OS, so that the thread scheduler will choose between these two threads based upon the priorities. Are you able to understand the concept? What I'm trying to say?
Yes, sir.
Okay, but the problem is here. It means JVM cannot control the operating system. I mean, JVM cannot instruct the, JVM cannot, give orders to the operating system. Let me repeat, JVM cannot give orders. JVM can't give orders to, or JVM cannot pass orders to OS. What does it really mean? JVM can give a suggestion. That's it. JVM just can give a suggestion, but it cannot pass orders to the operating system. Okay, JVM can give a suggestion, but it depends upon the operating system. Operating system can obey it or can't obey it. Even though through the program, when you make the T1 thread as the most prioritized thread, doesn't mean that OS is going to give the priority to the T1. It may or it may not consider the request. It may or may not consider the request. But what is the actual use of thread scheduling? You as a developer, you know that, okay, you can set the priority to the threads, but you cannot control it. You cannot control it in the sense, you cannot control it through these concepts, but you can control it to another concepts like, like sleep methods, like, like join methods, like wait methods. Through those concepts you can control, but through these concepts you cannot control. Sometimes what happens, even though you are giving the order, you are giving the instructions through the JVM to the operating system for the thread priority, JVM, the thread scheduler may, the OS may or may not consider it, but most of the time it will consider. Let me explain that for you programmatically. Let us say that I have a driver class. So class, I'm taking thread1. Thread1 extends thread. Okay, I have class 2. Class 2 is thread2. Thread2 extends thread. So 2 classes I have. So each and every class has its own run method. Run method. Okay, so inside this run method, I am going to keep the logic very simple. Integer I equal to 1, I is lesser than or equal to 5, I plus plus. Okay. This for loop is going to print something like low priority. Okay. And inside the another for loop, inside the another thread, I am overriding the run method. So here I am going to display something like high priority thread. The question is, okay, I am trying to create two different threads by the name of T1 and T2, but I want to set the T2 thread. I want to set this thread. Okay, I want to give the maximum priority to this thread. Maximum priority. Okay, how I can convey this? I can convey this through the JVM. So programmatically, how this can happen is, okay, first of all, what you usually do, you usually create the thread object, right? Thread T1, thread 1 T1 equal to 1 minute. New thread 1. Okay, likewise, thread 2 T2 equal to new thread 2. Okay. Two threads are born here. Two threads are just created. Okay, so they are just what? They are just started. They are in the new state. Okay, you are saying what? You are saying T1 dot start. So when I say T1 dot start and when I say T2 dot start, you don't have any control. Definitely the control depends upon the thread scheduler. It may give chance to T1 first or T2 first. We don't have any control. So what I'm doing is I want to give the priority to the thread T1, saying that T1 thread should get the min priority. There is a constant called min priority. Okay, among these two threads, okay, you have assigned a priority to the thread T1 and you're using a method called set priority method. Okay, so this is how you pass the information to the JVM, so that JVM will silently convey to the operating system, saying that, hey operating system, please make sure that T1 is getting a less priority. Just a kind of message is passing through the JVM. Next one is what? Set priority. Okay, now T2 is getting what? T2 is getting maximum priority. Okay, so priority has been set successfully. Okay, and the T1 dot start. Okay, T2 dot start. Okay, as per the program, through the program, so we are just doing what? We are just trying to set the priority for these two threads, T1 and T2. If you go back, this T1, in our case, this T1 has got the minimum min priority. This has got the min priority and this has got the max priority. As per the program, I'm saying. This min priority, this is max priority. Which means we are expecting the thread scheduler. Okay, there is a thread scheduler, isn't it? We are expecting the thread scheduler to execute all the instructions of the run method of T2 first. Execute all the instructions of the run method of T2 first, because thread T2 has been given the max priority. After prioritizing this T2 thread, come back to T1, then execute this because it has been priority. That is what our expectations are, right? That is what our expectations are. But the OS, okay, the OS are designed so beautifully nowadays, will not listen to the JVM because OS has its own set of instructions, own set of rules that needs to follow. It may not listen to the JVM. Most of the time, it will work. Sometimes it will not work. Let me show that for you. If I run this code, okay, you are getting high priority. This time it is working. Let me run it once again. Again, high priority. The high priority thread is getting a chance, but there are sometimes you will see the opposite. Again, this time also it is getting high priority. Time also are getting high priority. Now see, are able to witness low priority. Most of the time it will work, but sometimes it will not listen. Are able to follow? But your question, that should be a question behind your head. What is the question and what is the use of this min priority, max priority? Yes or no? Or, hello? Do you have such questions?
Yeah.
Huh? I mean, I'm saying no, this is useless. This is completely useless. As a developer, you are having some hopes. Okay, let it work for most of the times. You're not sure it should work for 100. I mean, you're not sure it has to work 100%. But you are sure that at least 50% your code should work, giving the priority to the maximum thread. If that is the scenario, you can use this. Okay, why it has become useless? Because through JVM you cannot control operating system. That's the problem. You have Mac operating system, you have Linux operating system, the Windows operating system. JVM is designed to talk to the operating system. JVM is designed to send, what kind of send a kind of give a kind of suggestions to the operating system, but it cannot control the operating system. If you want to have the 100% control of giving the priorities, you can use other things like you can go for wait, or you can go for we have discussed that, like inter-thread communication, right? You can make one thread to sleep for some time. You're able to follow, but this is a concept. Okay, you will come across this concept. Okay, when you do not want to happen this 100%, but at least you know that at least 50%. I mean, 50% of time it will work. Then you can go for this. You're able to follow.
Yes, sir.
What could be the answer in the interview? Very simple. What is the use of priorities? You can say priorities are used to what? They are just used to give the suggestion to the operating system through the JVM. JVM will be like, OS, please consider my request. But JVM, the OS may accept it or may reject it. You don't have that control. But you have one control. What is the control? You can give suggestions through the JVM to the OS. That control you have. But 50%, more than 50% it will work, but sometimes it would fail. If your situation is like, if your coding is like it should work at least 50, most of them it should work, then you can go for this. If not, you can go for the other things like wait method or notify method, or the sleep method. It depends upon the situations. Making sense? Hello? Yes, no? Okay, now next, this is completed. Okay, this is all about the priorities. You can give priorities. Okay, next, daemon threads and non-daemon threads. Okay, this is going to be very much interesting, the daemon and non-daemon. To understand this, let us say that through Java program, you have created, let us say you have created the 3 threads. 1 minute, guys. Through the Java program, you have created some at least 3 threads. Okay, you have created 2 threads. The thread one, this is T1 and this is T2. Okay, and what is the other thread you are going to have? You are going to have what? You are going to have the main thread, yes or no? Main thread is common. Main thread will always be there. Okay, and developers has an option to do what? As an option to create the own user-defined threads. So through our program, we have created these 2 threads. Okay, and as soon as the main thread starts getting executed, before the main thread, we know the concept of JVM, right? There is something called JVM, Java Virtual Machine, which is going to control our Java code. Okay, this is a kind of, it is like a brain of your Java code. It is going to control everything. Okay, so the moment you start the Java, the run button, it internally means the JVM gets activated. So it is a sign. Let us say that the green color indicates that JVM is activated. Okay, so when the JVM is activated, all it means is it it creates the main thread. Okay, and through the main thread, you can create user defined threads. So this is one user defined thread and this is another user defined thread. There are 2 threads. Let us say that, so there is some job. Okay, let us say that this T1 is supposed to complete this job. Let us say that some lines of codes are there in the run method, and T2 is supposed to complete this job. Few lines of codes are there. Okay, and main thread is assigned to complete few jobs. Okay, now don't you think that the thread scheduler comes into the picture, right? The thread scheduler comes into the picture. Okay, it is going to schedule time. It is going to give the CPU time for each and every thread according to the cycle, right? CPU time will be given, right? So now see all the threads that you have created separately, that you have created independently, along including the main thread, they are called as what? They are called as the non-daemon thread. I'll tell you what is non-daemon thread. The main thread is non-daemon thread. Okay, the threads that you have created, okay, by using the thread class, they are also called as what? Non-daemon thread. You know what happens? Let us say that main thread has completed executing its job. Okay, focus here. Let us say that main thread has completed executing all its job. Okay, now tell me, main thread will be destroyed or not destroyed? Or it will wait for other 2 threads to get to complete its job? Okay, can you tell me this?
It will destroy.
Okay, main thread is getting destroyed. So don't you think that when the main thread is getting destroyed, so the main thread is the only thread that is produced by the JVM, don't you think that when the main thread is getting destroyed, the JVM will get shut down?
Yes, sir.
Are getting my point? The main thread is getting the destroyed, JVM gets, when the JVM is getting shut down, don't you think that T1 and T2 will also destroyed forcefully? They might be executing, T1 might be executing this instruction and it has few more lines to execute, and T2 might be executing the first line, it has few more lines to get executed. Don't you think that there will be an interruption happen to execute the remaining kinds of code where the task has been scheduled for T1 and T2? If the JVM is getting shut down forcefully.
Yes, sir.
Okay. The question here is, main thread may get terminated. Main thread may get terminated, or main thread may get died. Okay. Main thread is what thread? Main thread is non-daemon thread. Okay. What JVM will do is, JVM will check, is there any non-daemon threads that is active in the Java program, current Java program. Okay, this is one non-daemon thread. This is one non-daemon thread. Yes or no? Okay. So this JVM will wait for this non-daemon thread to complete its execution. Okay, let us say that T1 has completed executing all its instructions. T1 will also get destroyed. Okay, T2 is pending to complete its execution. Okay, JVM will wait. J will not get shut down forcefully, even though the threads die. The question here is, you should check whether the threads are non-daemon. If the threads are non-daemon thread, JVM will wait for all the non-daemon thread to get, to complete executing its instructions. Are you able to follow?
Yes, sir.
Till that, it will not shut down. It will be active. Let us say that this thread 2, this thread T2 is executing a while loop forever. Executing a while loop forever. Which means the day JVM will not shut down. JVM will remain active forever. Are you able to understand what I'm trying to say? Why? Because they are non-daemon thread. What is a non-daemon thread? Non-daemon thread is a thread that is generated. It can be created by developers. Any thread that you're creating by default is a non-daemon thread. Okay, whenever there is any non-daemon thread active or executing in instructions, okay, the JVM has to wait until it completes its execution. Okay, now the problem, okay, where you will face a problem, if you make any thread as a daemon thread, then the problem comes. If you make any thread, let us say that if you make the T1 thread as, instead of daemon, non-daemon, if you make it as daemon, okay, so let us say that T1 is daemon now, other two threads are non-daemon. Now the control is going to be working differently. JVM is going to work differently. What JVM is going to do? JVM will only wait for executing the non-daemon threads. Okay, it will wait until this instruction gets executed and main thread gets executed. It will wait only for these two threads. Even though the daemon thread is has got stuck in the second line. Okay, the forceful shutdown will happen. I will explain that to you programmatically. Literally what I'm trying to, strictly speaking, JVM will never wait for daemon threads. Have you got some idea about daemon thread? Question is why daemon threads are there. We will understand that. Literally, you can create your own daemon threads based upon the requirement. Sometimes you have to schedule some task behind the scenes. For example, so let us say you are visiting a restaurant. Okay, so in the restaurant, the manager will be there, chef will be there, everyone will be there. So restaurant keeps running until it's until it is closed. When it is closed, what I mean by when it is closed? It is closed means the manager or chefs, everyone are have completed their work. They are shutting down the shutter, right? So during the time, so there are some jobs. There is some jobs like cleaning job, right? So restaurants, some big restaurants, they have the robots to clean the to clean the premises, restaurant premises. Okay, no matter what, as soon as the restaurant, as soon as the manager and chefs they come out from the restaurant, definitely the robot will be shut down automatically, even though their cleaning work is pending there, because it is not really a big matter for them. Some task will be there that is not a big matter. They can run until the restaurant is functioning. As soon as the restaurant stopped functioning, they should also stop functioning. They don't care whether the cleaning job is pending or they don't care. They just shut down and go. The same concept can be applied in Java. For the garbage collection. Okay, for garbage collection is nothing but memory. You have to, when you manage memory leaking. Okay, you have to clean memory programmatically. When you want to clear memory programmatically, these are the background jobs. So logging or monitoring. So you can monitor your code, you can monitor the metrics only if the code is running. Okay, so these are not the big tasks. Okay, the JVM should not wait for all this. They should be running until the JVM is active. The JVM is shut down, they should be shutting down along with the JVM. So JVM should not wait for these jobs like garbage collection, like logging, like monitoring. They're okay. You can interrupt them in the middle. Such kind of jobs has to be given to what? Given to what? Given to the daemon threads. Able to understand?
Yes,
Any
sir.
job that is not completely irrelevant. I mean, irrelevant means it is Not a big deal. Okay, it is not a big deal to wait for the job to get completed, but it can work as long as your JVM is active. If you have such jobs, okay, give the jobs to the daemon threads. Make those threads as daemon threads. It will make more sense. They're not really important. Okay, programmatically you will understand that. Okay, let me design a small program for that. Let me remove this. Let me remove this. Let us say that I have the class worker thread extends, or let us say chef thread, chef in a restaurant. Okay, inside this I have a run method. I'm overriding the run method. So this run method, again a for loop, a simple for loop, integer I equal to 0, I is lesser than or equal to 5, I plus plus. So simply I am using something like worker thread, say, okay, chef thread. Chef thread is a non-daemon thread, which means JVM has to wait until the chef thread completes its job. But chef thread is a non-daemon thread. It is working. After this, to visualize this, I'm just making this thread to sleep for some time. So 1 second. It has to get caught. I'm using some. As soon as the thread comes out of this, I mean, as soon as the for loop gets executed, I want to print a statement like if thread has completed its. Very simple analogy. If you have a chef thread, one run method is there. Inside that, you have a for loop. Just printing chef thread is a non-daemon thread. So all the threads that you are going to create is basically a non-daemon thread, which means JVM has to wait until this chef thread completes executing its instructions. That is the idea here. Okay, let us say of class cleaning thread extends thread. You have another class cleaning thread extends thread, and again you are overriding the run method. Run method. So inside this, I'm going to keep a different logic. I'm saying something like integer I equal to 0. I'm taking a while loop. So you are setting this thread to work forever. When I say forever, means until the JVM is active, this thread has to work. This thread has to clean the, do the cleaning work until the JVM is active. The JVM is shut down. This thread should also shut down. Okay. System.out.println. What you are saying? Uh, cleaning thread. Say non-daemon thread, and it is you are just trying to print the value so that you can visualize whether the work that is going. So you are saying thread dot sleep. Let us make it to sleep for some 300 milliseconds. Surround the threadless. Right now, in the driver class, create the two thread objects. So one is cleaning thread and the second one is the chef thread. Okay, chef thread cf equal to chef. Okay, by default cf is what? Cf is the non-daemon thread. You are not being very specific here. By default all the threads are non-daemon thread. So next one is what? Cleaning thread. Cleaning thread clean equal to new cleaning thread. Okay, but you want to make this cleaning thread to be a daemon thread. So what you are doing is you're using this clean dot set daemon method is there. Okay, you will pass the variable as true here, which means CF is a non-daemon thread, which means JVM will wait for CF until the CF completes its job. JVM will wait. But clean is what? Daemon thread. Daemon thread means JVM will not wait until the JVM is active. Cleaning will be doing its work. Will be completely doing its work until the JVM is active. Once the JVM is shut down, it will also shut down along with the JVM. Which means JVM will not wait for the thread. That's what I'm trying to say. Okay, after this, what you are doing? CF dot start. Okay, and clean dot start. After this, I just want to play something like main thread completes the work. So how many threads totally you have here? On line number 45, you have okay 3. You have main thread here, line number 45, and again you have main thread here. Okay, and this CF is what? Non-daemon thread. This clean, from here the clean becomes what? Clean becomes a daemon thread. So you have one non-daemon thread, you have one daemon thread, and you have main thread which is also non-daemon thread. So two non-daemon, one daemon thread. Okay, you are starting the CF, you are starting the clean. Both are going to do its job peacefully. Okay, chef method is going to run this job. Cleaning method, when you see cleaning method, it is always found to be true. Okay, it is an infinite loop. Okay, since it is a daemon thread, as soon as the JVM shutdowns, when is the JVM will shut down here? When the JVM will shut down here, as per our logic, JVM will shut down when EF completes its job and main thread completes its job. Yes or no? Yes or no? Yes or no? So it will not wait when the clean thread is doing its work, right? Well, as soon as it shut down, whatever the work done by cleaning thread, it is okay, it is fine, but it has to get shut down also, because no, the job is given to the cleaning thread in such a way that it should be active when the JVM is active. It should be inactive when the JVM is dying. Run this code. Be able to witness the difference. Chef thread has completed its job. So now you see main thread has main thread completed its job. Okay, still JVM is active. Why? Chef thread has started working 0. Okay, but cleaning thread has done 4 jobs. Chef thread 1, cleaning thread has done some job. Chef thread 2, cleaning thread has some job. Chef thread 3, cleaning thread. Chef thread 4, cleaning thread. Okay, the moment the chef thread completes its job, the JVM is getting shut down. Are you able to witness here? The cleaning thread, it is not repetitive here. It should be repetitive, right? Because you have placed a while loop there. It should be infinite, right? Okay, if you're not setting it to be, you just removing this, then the output could be completely different. Okay, it is going to be an infinite, right? Because now the clean thread is also what? Clean thread is also a non-daemon thread. JVM has to wait until this thread completes its job. It will wait forever, yes or no?
Yes, sir.
You're able to understand the difference. So why these things are necessary? Why these things are necessary? You will understand this in the Java project. I'm stressing this much because we'll definitely get this in the Java project. Java project, we have a concept called Tomcat server. Okay, your time you can, have you ever heard about this Tomcat server?
Yes, sir.
It is a software server. Okay, it will run on a particular port number. Okay, default port number is 8080. It will listen to this port. The server will listen to the particular port to check whether the HTTP request is arrived or not. This Tomcat server will run on the non-daemon thread. I will give you that picture when I start when we start building the application. So this is making sense now, daemon and non-daemon thread.
Yes, sir.
Perfect, right? So let us understand about what third one is. What third one is? Deadlock situations and the starvation. Okay. Now if you see,
Sir,
tell me.
termination means అంటే కంప్లీట్ గా టెర్మినేట్ అయిపోద్దా
Yes,
JVM like
yes, yes, yes,
system.exit
yes,
లాగా.
yes, yes.
Okay.
See, termination means correct, correct. Termination means you have started. The program is started. You are able to see this red icon, right?
Yes, sir.
Okay, the demon thread is not true. Let me say, let me remove this. When you see this, JVM is active. Now JVM has shut down. Are you able to witness it?
Yes, sir.
This is a signal for us through this editor, and we can also check this in a different way. So now application is not in the run mode. Again, you have an option to hit the run button once again, which means you are starting the JVM once again. That is getting shut down once again. But in the real-time project, what you have to do is you have to ensure that the JVM remains on forever, which means you are using the JVM. You are going to use this JVM. You're going to activate this JVM so that through the JVM, the particular server remains active forever. In our case, Tomcat server. Okay, you have to ensure that the Tomcat server should be activated forever. Activated in the sense you have to accept the request and you have to send a response. The server should be active always. When you want to make the server to activate always, you have to create the server to a non-daemon thread. Okay, so now JVM will remain active because server is active and server is created because of non-daemon thread. This is a kind of attachment that the non-daemon thread has with the JVM. Able to follow? You don't understand. You really
Yes, sir.
will not understand this now. When I start creating the application, things will make more sense. Okay. For now, just try to understand. JVM will always wait for all the non-daemon threads. That understanding is more than enough now. Right? Now let us talk about what? Let us talk about the deadlocks. So deadlock is very simple. Deadlock situation is nothing but when two threads are locked each other, which means let us say that there are two objects. This is O1, this is O2. Object 1 and object 2. Object 2. So you have thread T1 here and thread T2 here. Okay, so this thread T1 has acquired the lock of O1 and thread 32 has acquired the lock of O2. Okay, and so this thread T1 has two operations. Okay, it has a synchronized block. Okay, within this block there is another synchronized block. A block within a block. Let us say that a block within a block. Now two synchronized blocks. This block, the first one is holding the O1 object. I mean the object 1. Second one is holding object 2. Okay. Likewise, in this area, in the thread T2, it is going to run it is going to call the run method respective to this thread. Okay. And it has the object locks like this. Look at the order O1, O2, O2, O1. Right? Whichever the thread is getting chance. Okay, let us say that T1 is getting a chance. Okay, so O1 means the lock of the O1 object. You know, right? O1 any object has a monitor and it has a lock. This has one lock 1 and this has the lock 2. Okay. So the lock 1 object is acquired by this synchronized area. Okay, and the lock 2 object is acquired by this thread to this synchronized area. Focus here. Both have acquired their different independent locks. It has lock 1, it has lock 2. But to execute the remaining instruction, okay, there is another synchronized block here which is expecting lock 2. Which is expecting this lock 2. Okay, there is another synchronized area in the thread, I mean in this run method, which is expecting what? Which is expecting the lock 1. Okay, this lock 1 will not be released until the complete synchronized block, outer synchronized block get executed, and this lock 2 will not be released until this synchronized block, outer synchronized block get executed, which means this thread T1 is expecting this expecting lock 2 and T2 is expecting lock 1. Deadlock situation. Are you able to understand? You will understand this
Yes, sir.
programmatically. A common idea. when one thread is expecting another lock and the another thread is expecting another lock on each other, deadlock. This lock will not be released. This lock one will not be released until this synchronized block gets executed. To execute the synchronized block, it needs lock 2, but lock 2 has been acquired by this thread. What this thread is doing, I will release only this lock when you give the lock of when you give the lock 1. But lock 1 is here. This cannot be released because it has to execute this. And this lock 2 will not be released because it has to execute this synchronized block inside the synchronized block. They are locking upon each other. This is called as what? Deadlock situation. Able to follow?
Yes, sir.
You will not follow. Okay, you will not follow. I understand, but you need to do the tracing. Let me show that programmatically and how you can resolve this deadlock situation. You will understand that. Okay, let's see. Remove this. Very simple program. Let us take class get lock thread 1. Next. If you log out of the meeting room, please rejoin. Okay. Class thread 2, because I have to give you the syllabus for Java project. Only 4 days. I will give you the complete knowledge on the Java project. What are the things you are going to learn? Everything I will give. Within those 4 classes, you can learn a lot. Okay. So let us okay. Let us say that 2 dummy objects, private object 1, object block 1, okay. Private object block 2. So let me generate the constructor. So these logs will be given from the main method. Okay. Generate constructors using builds. Okay. So I am overriding the run method. Now actual cinema will start from here. Run method. Inside this run method, I am keeping a synchronized block. This synchronized block is going to hold the log 1. Inside this, I am displaying something like system.out.println. So thread 1 holding log 1. Focus here. Thread 1 is holding log 1. So let us make the thread to sleep for some time so that the other thread will get a chance to visualize this deadlock. Thread dot sleep. Let us make it to sleep for 100 milliseconds. 100 milliseconds. Let me cover with try and clash block. Okay, this is the outer synchronized block. So what I am doing, inside this I am keeping one inner synchronized block here, which is expecting log 2. So this synchronized block is inner. This is inside another synchronized block. Synchronized block is part of another synchronized block, nested synchronized block. Are you able to follow this?
Yes, sir.
Now I am saying here, now in this block I am saying thread 1 is supposed to acquire log. Acquiring log 2. So now tell me, whenever a log, so this run method is acquiring log 1. It is acquiring log 1. Okay, by using this log 1, it executes this. Okay, it sleeps, it waits for 100 milliseconds. Okay, and it will stop here to execute the remaining instruction from line number 25. Okay, the lock is still there. It has log 1. Till here it has log 1. But to execute this, it need log 2. Okay, it will wait for log 2. But this log will never be released until it comes out of this run method. Yes or no? Only it comes out of this run method. I mean, not run method. Only it comes out of the synchronized area, the log will be released. Able to follow?
Yes, sir.
It will stick to that. It will keep that log. I want to execute my synchronized block. I have acquired this log to execute my synchronized block. The synchronized block is very big, but unfortunately, it has encountered the line number 26, which is expecting another log. Okay, it will blindly wait. It will believe and it will wait. Okay, log 2 will be given in some time. It will believe and it will be waiting here. But in the other place, what is happening? Okay, so you have the deadlock situation now. In other place, what is happening? Let me copy this. Okay, you have the deadlock thread 2. Let me paste it here. Okay, this is thread 2. Okay, and inside this thread 2 you have another similar condition. Okay, synchronized area. You are using the synchronized area, and now this is expecting log2 first. System.out.println thread 2 holding log2. Log2. It started holding log2 first. Let's acquire the log2 first. It wants to sleep for some time. Dot sleep. Okay, for 100 milliseconds. So let me cover this with dry glass. Okay. After this, I am deliberately placing another synchronizer block, a synchronizer block within a synchronizer block. It is expecting log1 here. System.out.println. Okay, thread to acquire log1. So just a statement. Just a simple statement. So it is similar to this imagination. Okay, you have two thread T1 is executing these blocks, thread T2 is executing these blocks, but they have acquired different locks. So this has acquired log1 first, it has acquired log2 first. Then the problem comes. Okay, to execute the remaining block, nested synchronized block, it requires log2. But to execute this nested synchronized block, this requires log1. Are you able to follow?
Yes, sir.
Both will not release, because the problem here is lock will be released only it successfully execute the synchronized area. Lock is stuck. Lock is like, it is very stubborn. I will not release until I execute my synchronized area. The lock T is also very stubborn. Same thing we are visualizing it here. After that, what I can do, I can create two dummy objects. Object O1 equal to new object. Okay, and object O2 equal to new object. Okay, deadlock thread 1 D1 equal to new deadlock thread 1. So I am passing two objects. Object 1, object 2. D2, object 1, object 2. This D2. This D2. Okay. D1 dot D2 dot. Okay, from here, from here two threads are getting started, right? Two threads are getting started. So it has two object references here, object 1 and object 2 reference here. Okay, but the moment what is happening, even though who is getting the chance first, the deadlock thread 1 gets chance first, it acquires, it finally catches lock 1. It takes lock 1, but this is taking lock 2. Both are taking two different locks. Okay, and it is going to execute according to the CPU time. This will get executed. It is going to see it for 1 second. Now here it will stuck. It will be waiting for log 2. Will be waiting for log 2. So on the other hand, a thread T1, I mean T2 thread, it takes log 2 first, and here it is waiting for what? Waits for log 1. So when it is going to get log 1, only if the log 1 completes executing this synchronized data, right? Only the log 1 has to come here successfully, but it is stuck here. It is waiting for log 2. So on the other hand, this log 1 is waiting for what? When this log 2 is waiting for what? Waits for log 1. Log 1 is there. So both are not very much stubborn. They are not ready to give the logs because they are in synchronized area. Their duty is they have to come out of the synchronized area. But it is not possible. Run this code. That's it. It is holding the log. Thread T1 is holding, thread T2 is holding, but they are not acquiring the log. They are not able to acquire the log. Are able to see it is still running. JVM is still active. JVM remains active forever. No job will be done. They both will be in the locked state, deadlock state. A CPU thread scheduler will still giving the time. It is going to give the time to both the threads, but both the threads are stuck in the locked condition. Able to follow?
Yes, sir. Can't we save them, sir?
Want we? We can save. Good question. Good question. We can say the problem. What is the problem here? What the problem? Look at the problem. It is a good question. We can say so. The lock situation, deadlock situation occurs because of developer's mistake. Yes or no? Multi-threading is
Yes,
designed in such a way deadlock comes because of developer mistakes. We cannot blame Java program. Java program will do what we are instructing it to do. Yes or no?
yes, sir.
Now you see what is the solution here. Now look at this code and the solution is here itself. Instead of if you say O1 and O2, let us say that we are organizing it like the order is like here. The order is like O1, outer block is taking O1, inner block is expecting O2. But here outer block is expecting O2, inner block is expecting O1. Opposite, right? If you keep the order, problem solved. You say O1 and O2.
So both should be same.
Both should be order should be. If you keep the order same order, there is no possibility of getting deadlock situation here. Yes or no?
Yes, sir.
Just this change. Just if you place the order same, thread scheduler happily give the scheduling to both of the threads. Okay, any thread, any point of time, it can access what? It can access the other lock. Other lock will remain. Other lock will be here. Other lock will be remain. It is going to stay with the object itself. No one has acquired the other lock. Both are going to share one lock together. One lock will be shared between these two threads until it executes the outer for loop. Okay, then it dumps. Other lock will be taken by this and this. No issues. Problem comes only when, okay, when this lock is taken by this one and first in the beginning itself, and this lock is taken by this thread in the beginning itself. Problem started. If they share the locks sequentially, no problem. No? That's why you have to make sure that the sequences are changed. Okay, order is changed just by changing the order. Okay, grasping this is going to be a bit difficult at the beginning. Just to try to trace it from your end, you will get 100% out of it. Let's see. I have just changed the order. See, everything is perfect now.
Yes, sir.
JVM is also shut down now. Happy. No issues. Understood about this concept? This third one,
Yes, sir.
deadlock situation. Now starvation. Okay, starvation is, we have already covered the starvation. Starvation is nothing but when you make any thread to wait for some time. In a previous example, you have created the low priority thread, if you remember, low priority thread, right? Which means this low priority thread has to wait in the sense it is not an ordinary wait. Ordinary wait means there is a concept of notify and there is a deliberate wait. Okay, that is this waiting is like you have to wait for the thread scheduler to give the CPU cycle, which means you are deprioritizing this thread, which means the thread is in starving, which means it is waiting for the CPU cycle. The low priority threads or the mean priority threads are called as what? The threads that are in starvation, which means even though it has a lot of job to get executed, the priority is not given on time, so they will be in starvation. That is the simple understanding about the starvation. Able to follow?
Yes, sir.
Can I jump into producer and consumer?
Yes, sir.
Everyone are there or everyone left out? Everyone are there. I'm happy to see. Let me take new file. Okay, so now we have understood something about what the inter-thread communication. So this inter-thread communication is going to solve a problem which is called as what? The producer and the consumer problem. Question is, what is this producer and what is this consumer? Okay, any thread can be a producer and any thread can be a consumer on a common object. It's a common object. Let us say that this is a producer Producing data is consumer, consuming data. But the rule here is, okay, this is an object, common object, okay. The rule here is, it can consume only if the data is there. Okay, this thread can consume only if the data is there. This can produce only if the data is not there. I mean, it can push the data only if it is empty, if the object is empty. For example, okay, let us say that this producer has generated a number 0, is placing it in the object. Okay. Now, don't you think that there is a data to consume by the consumer? Now, the consumer can act on this object. Data is there. But at this point of time, consumer can act, but the producer cannot produce the data because already data is produced. It has to be consumed, then it can produce another data. Okay, threads, they don't know data is produced or not produced. How the developers can make it work? They can use the concept of inter-thread communication. What they can use, they can combinedly use the wait and notify method. What do? You make a common object. You make the producer to wait until the data is consumed by the consumer, and the vice versa. So now which thread will act? Okay, now there is a data here. Which thread has to act? Which thread has to consume this data? B or C? Since data is there, consumer thread will consume this data. Okay, now data is not there. Which thread has to produce the data? B has to produce. Has to put the data because data is not there. The job of the producer is to put the data. Has to put the data. Okay. Now again, the same job cannot be done by the producer because data is already there. Only it can produce data when the data is not there. It cannot produce two once again. It cannot do this because the existing data should be consumed. Simple topic, okay. It is a kind of, I'm going to give a generic example. You go to the restaurant, okay, and if you they place the plates, right, you cannot consume food when there is no food on the plate, right? Hello.
Yes, sir.
Only when the food is placed, biryani, whatever it is, then you can start consuming. You start consuming, if you start licking the plate without being served, what does it really mean? So we know as a human, we are clever enough to when to consume and when not to consume, right? So how the threads know? How the threads communicate? The simple producer consumer problem where you get a situation that like this. If you want to consume, a thread can consume only if the data is there, and the thread can produce only if the data is not there. Then you go with producer consumer concept. It's a simple topic to demonstrate the complete picture about the wait and notify. Nothing else. You can do a lot of things. It's a simple demonstration that I can give you to understand better about the wait and notify. Able to understand?
Yes, sir.
Let's jump into the code. I think you get knocked out of the meeting room. Okay, let me write the code. Let me write the code till that. Code is very simple. Plate, okay, the plate that I'm talking about in the restaurant, that is a common object for both the person who comes there to eat and for the person who serves the food. That is a common object. So likewise, I'm going to take a shared buffer as a common object. A simple name I'm giving shared buffer, a common object. So we are going to produce a number. Producer is going to produce a number, produce a data. Okay, and I'm going to have a field, a boolean field, is going to change between true and false based upon the message given by the producer and the consumer. If the producer produces, it turns to be true. Okay, if it is true, the consumer consumes and it again turns it to false. If it is false, the producer produces. My screen is visible, right? My voice is also audible, isn't it?
Yes, sir.
Okay, now see, okay, the data which is going to be common for both the producer and consumer, and it is a kind, this boolean available is a kind of switch. Okay, you go between on and off. Okay, false and true, false true, false true, false true, depends upon whether the data is consumed or produced. Okay, that changes will be happen. It is like a common switch. It is a kind of a signal. Okay. Now what I'm doing is I'm taking a method, synchronized method. Synchronized void produce method. Okay. So when you call this produce method, you have to pass a value. When you pass value 0, 0 will be produced. When you pass value 1, 1 will be produced. Okay. Inside this, I'm keeping a while loop which is expecting the available as a parameter. Focus here. This accepting this boolean variable as a parameter. Okay. And if it is true, then it waits. If it is true, then it waits. Let me throw this. Okay. So if it is false, false means what? According to the producer, false means what? False means the data is not there. Data is not there in the common object. So what it does, it consumes the value and assign it to the common data variable. Okay. After doing this, it will try to modify the boolean field to true. Means it's saying I have produced the data. Data is available. True. Okay. After the system.out.println produce a simple message to to check it from your side. Produced what so and so data. Data is produced, then notify. Enter that communication is happening. At any point of time, do you think that from line number 11 to 18 gets executed sequentially? Either this will execute, this block will execute, or this block will execute. Yes or no? When this is getting executed, this thread will wait. When this is getting executed, the other thread has to get notified. Are you able to see the the uses of wait and notify method? When you say wait, there is going to be another method which is going to start consuming the data. Okay, when it is going to wait for the other method, I mean other thread. Wait means it is going to wait for the other thread. Notify means it is going to communicate, give the notification to the other thread. Okay. So when you use this, definitely there should be another thread that should be acting upon, right? So the another thread is what? The consumer. Synchronized void. Okay, focus here. Now this consume is just going to accept the opposite. Okay, not available. By default, at the beginning it is false. The beginning false. When I do the not operator, it means this while loop becomes true, right? Condition becomes true, right? Yes or no?
Yes, sir.
See, I'm keeping available here. I'm keeping available not available here. So based upon this common value false. Initially it is false. False means this will not get executed. This will get executed, which means at least one thread is going into the waiting state, right? At any point of time, at least one thread is blindly going to the waiting state. Are you able to follow?
Yes, sir.
Because we are designing like that. We are designing like that so that the two threads can communicate gracefully. That is the idea here. Okay, after this, system.out.println consumed plus data. This is not executed. If the notification is given, okay, this gets executed. Okay, now it is going to change the available to false. Okay, wait and available to false. After this, it will notify the other thread, the producer thread. Then this is the common object, common shared object. Think it as like a restaurant plate. Okay, think it as like a restaurant plate. When the food is served, okay, this thread will act. One more, this is missing. When food is served, this will delay. When food is not served, this will act. Are you able to follow? Common plate. It's a common plate, right? So here, let's start executing the thread. So Java communicates through thread, right? I'm saying class producer extends thread. Okay, another class I'm taking class consumer extends thread. So this producer, let's keep the private object shared buffer. Shared buffer. So let us create a constructor for this. Generate constructor using fields. Okay, so this is going, since it is extending to thread, you have to override the run method, right? So run method. So inside this run method, you are keeping a for loop to witness the production and the consumption is lesser than equal to 5 I plus plus. Okay. Now by using this reference variable shared buffer dot, you call the produce method and you pass the value of 5. Okay, and this is going to throw an exception surrounding with try and catch block. Let us make it to sleep for some time to witness it, to witness a simulation. 100 or off second. Okay, done. So job of the run method is done. Okay, now consumer. Consumer is also going to have the private shared buffer. Shared buffer. Source generate constructors using fields. Okay, and again you have to override the run method. Inside the run method, same for loop. Feature I equal to 0, I is lesser than or equal to 5, I plus plus. Buffer dot consume. Okay, these two threads are meant to act upon the common synchronized areas, or no? The consumer and producer, they are meant to act upon the common synchronized area. Going to throw an exception. Okay, and let us make this sleep to 1 second. Get dot sleep 1000 milliseconds. 1000 milliseconds. Okay, now the main method shared buffer SB equal to new shared buffer. So this object is expected for the producer thread class. Producer P equal to new producer SB. Consumer is also expecting the same object, but they are this object is what, this SB is part of the synchronized area. It is going to have a lock, but lock will be shared between producer and the consumer. Okay, that's it. P dot start, P dot start, T dot start. Okay, let us see what is happening. Producer 0, then consumed, producer 1, consumed, producer 2, consumed, producer 3, consumed, 4, consumed, 5. What we are understanding on this output? Okay, the consumption is not starting before production. The production is not starting when the data is already produced. Able to understand? I mean, looking at the output, we can give a judgment like two threads are communicating through the wait and notify method. First conclusion. If you want to demonstrate this, see, only three objects we have created. One is SB. You can imagine it like, okay, this is an SB. This object is an SB. Common log. This is what SB. Okay, and there is a monitor for every object. The monitor is going to have the log. Okay. Now let us try to understand the thread scheduling job. Two threads are created. So we don't know who is going to get the CPU time first. We don't know who is going to get the CPU time. Okay. We're not sure who is going to get the CPU time first. Let us say that thread T1 has got into this produce method. So available is already false. So it will not go into the wait condition. It will start production. But on the other hand, thread C2, since the value is set to false, available is set to false in the beginning, there are high chances that consume method will start waiting in the beginning. Are you able to follow?
Yes, sir.
Because this is the common false. Okay? Completely, this while loop will never get executed. The other while loop has to get executed. So one thread is going to the wait state in the beginning. In this case, consume method is going to the wait state. It is waiting. When it is waiting, the lock is with producer. Producer is producing and notifying. Producer is producing the data. Data is produced. Okay. What data? Value. What is the value? Value is being triggered from the for loop from 0 to 5, right? From 0 to not from 0 to 5. 0. First value 0 is produced. After producing 0, notify is notifying. Notifying means, okay, now the thread will woke up. Okay, the thread, where is the thread? Yeah. Okay, and this notify. This notify will do. Line number 18 will enter. The thread will enter line number 18. Now this wait. Okay, and it will check the while loop again. But this time it has changed it to true. After changing it to true only, okay, it is encountering the wait method. It is getting wait method is getting notified. Again, it will not enter into this while loop once again. It will come out of the while loop. Are you able to follow? Instead of while loop, if you place if condition, there will be deadlock. Do some research on why there will be deadlock if you place if condition. You place while condition, it is since a repetitive statement. Okay, before notifying, it is setting the value to true. When it is setting the value to true, which means, okay, this becomes opposite of true is what? False. Opposite of true is what? False. The thread is already getting wait, will be released. Okay, then it starts consuming. After consuming, it is setting to false. Okay, this is like a switch. Okay, available is like a switch, false and true. It hovers between false and true. Based upon this, okay, this available value gets changed. Okay, according to that, the logs will be, I mean, the wait method gets acted. When this is getting acted, this completes its consumption work. When this is getting acted, when this is getting acted, this produces its work. This line, when this wait method gets encoded, these lines will get executed. Okay, when this wait method gets encountered, these lines will get executed. It keeps oscillating between these two synchronized areas. I will give this code. Try to do some research. Research should be like, okay, you have to start from the basics, from the thread scheduling. You should understand about the thread scheduling also. You should involve the thread scheduling also. Okay, and what happens when you change the while to if condition? What is a big deal there? Okay, this is the perfect example where you can completely understand the inter-thread communication.